A bouncy ball rolls off of a counter at a height of 4 feet and rebounds 5/6 of the distance it previously fell. How far does the ball travel vertically before coming to rest? All right, so we've got this counter. The ball falls off. And so initially here, the ball on its way down, it falls 4 feet. But then it bounces up, and it doesn't bounce all the way up. It's only going to bounce up 5/6 of the distance it previously fell. So it fell 4 feet initially, so we need to multiply by 5/6 to figure out how far it rebounds. So that would be 20 over 6 or 10 over 3, essentially 3 1/3. I'm going to leave this as an improper fraction though. So it goes up and bounces up now. It looks like 10/3. And then it falls again. So if it bounced up 10/3, then it's going to fall that same distance, 10/3. But when it bounces once again, it doesn't go back up the total height from before, but rather only 5/6. So we have to do this again. 10/3, what's 5/6 of 10/3? So that looks like 50 over 18. In other words, 25/9 would be the distance that it's going to rebound this time. And then it'll fall that amount, and you can see this pattern is going to continue as it rebounds and falls and rebounds and falls, and so on. So we want to know how far the ball has traveled vertically before coming to rest. So we basically want to add up all of these distances. We have to take a look at all the distances that the ball travels downward. So those would be depicted here in orange. Those are all the downward motion, the falls. And then we also need to add up all of the distances that the ball traveled up. Now you'll notice it fell 10/3 and it went up 10/3. It fell 25/9 and it went up 25/9. And wouldn't that actually be the same for all of these subsequent bounces? However, the initial one, it fell 4 feet, but it did not rise. It didn't bounce 4 feet. It only fell 4 feet. So one way to attack the problem would be to look at the sequence and basically look at all of the downs, the distances that the ball has fallen down, versus all of the ups, the bounces upward. So the downs, initially it fell 4 feet, and then it fell 10/3, and then it fell 25/9, and on. But the ups, it didn't go up 4 feet. It first went up, or bounced, rebounded up 10/3, and then it rebounded up 25/9, and so on. So we want to add all of these terms up. We need to add all of the downs and all the ups together. So we essentially have a sum that we want to compute. And one way to do it is to compute the sum of all the downs and the sum of all the ups, and then put the two together. So when we take a look at the pattern that we have here, we know that to go from 4 to 10/3, we multiplied by 5/6. And again, from 10/3 to 25/9, we multiplied by 5/6. So that's telling us that our sequence here is geometric. And we also know that my common ratio, what I multiply by repetitively, is 5/6. Now, do we know the last term of the sequence? Where is this going to end? Well, in reality, of course, the ball will stop bouncing eventually. But mathematically, basically, we would have to keep multiplying these up values and these down values by 5/6, and we would just keep doing that repetitively. We'd keep doing that forever. So essentially, this becomes an infinite geometric series that we're interested in computing. So we want to find the limiting value of this infinite geometric series. And we know the sum of an infinite geometric series can be found by dividing the first term by 1 minus r. So let's go ahead and do that for each of my sequences here. Essentially, though, we're not looking at the individual terms. We want to actually add these terms together. So really, it's a geometric series like so. All right, so let's take a look at the downs first. So the first term in this series is 4. So the sum for the downs, it first fell from a height of 4 feet, divided by 1 minus r, and r is 5/6. Remember, when you go to enter this in your calculator, it's extremely important that you have parentheses around that entire denominator to be sure that you're dividing by the whole quantity, 1 minus 5/6. So it looks like that's a total of 24. So that would be 24 feet. So the ball falls 24 feet, but then it rebounds on the way up some additional feet. So let's see, the first term here, though, on the way up is 10/3. However, the common ratio is still the same. We're still multiplying by 5/6, so that would be 10/3 divided by 1 minus 5/6, which looks like it gives me a total then of 20 feet. Which should make sense to you, right? If we thought about this, if we know that on the way down it was a total of 24, the only difference in the value really is 4. So this second computation is not really necessary if you think through the problem. Once you found out that on the way down it fell 24 feet total, then 4 less than that would have to be the total distance that it rebounded up. So then we want to put these two together, and that'll be the total vertical distance that the ball has traveled. In other words, our final answer here is going to be 44 feet. And we call that the limiting value of this infinite geometric series.